Good morning, everyone. Good morning, students. Welcome to the webinar series of Telangana State Model Schools. Today, we are going to start with mathematics session, and this mathematics webinar series. In the previous class, we have discussed a pair of straight lines, lesson 2, as a part of mathematics paper 1B. Now today we have with us Sri K.SRINIVAS Garu, PGT Mathematics, working at TSMS Ambam, Varni, Nizamabad, a very distinguished speaker and a passionate teacher. So make use of this session, and over to you, sir.
Thank you, madam. Thank you very much. Good morning, everyone. Once again, welcome to Mathematics Paper 1B webinar session. Our topic is pair of straight lines. In the previous sessions, we have discussed about that combined equation of two straight lines. Suppose L1 equal to 0 and L2 equal to 0 are any two straight lines, then the combined equation of those two straight lines will be L1 into L2 equal to 0, which has suppose L1 equals to A1x plus B1y plus C1 equal to 0 and A2x plus B2y plus C2 equal to 0, then the combined equation of these two will be L1 into L2 equals to A1x plus B1y plus C1 into A2x plus B2y plus C2 equals to 0. And second degree homogeneous equation. So the second degree homogeneous equation is of the form of ax square plus 2hxy plus by square equal to 0. And that second degree general equation in x and y variables. So it is of the form of ax square plus 2hxy plus by square plus 2gx plus 2f plus c equal to 0. And the equation h equals to ax square plus 2hxy plus by square equal to 0 represent a pair of straight lines which is passing through the origin if and only if h square greater than or equals to ab. And we have discussed about this theorem also. And that one more important theorem also we have discussed in the first session, that is finding the angle between the given pair of straight lines. Suppose the equation of the pair of straight lines is ax square plus 2hxy plus by square equal to 0. That is already we have discussed that is the equation of the pair of straight lines which is passing through the origin, and that angle between those if theta is the acute angle between them, then we have derived that cos theta equals to modulus of a plus b by under of a minus b whole square plus 4s square. After that we have concluded, we have one more condition also we got from the using theorem only. So that is a condition of pair of straight lines to be perpendicular to each other. Suppose the equation of the pair of straight lines is ax square plus 2hxy plus by square equal to 0 is given. Then if the given pair of straight lines is perpendicular to each other, or if the angle between them is theta equals to 90 degrees, then we got one condition, that is a plus b equals to 0. Nothing but the coefficient of x square plus the coefficient of that y square will be equal to 0. Afterwards, we have discussed about the bisectors of angles between two straight lines. In the second session, we have discussed that the bisectors of angles between two straight lines. Suppose L1 equals to a1x plus b1y plus c1 equal to 0, and that L2 equal to a2x plus b2y plus c2 equal to 0 are any two straight lines. Then we have derived that formula or derived the equations of the angles of bisectors are, that is a1x plus b1y plus c1 by under root of a1 square plus b1 square equals to plus or minus a2x plus b2y plus c2 by under root of a2 square plus b2 square. So in this case, plus or minus symbol will be there. That's why we will get that by taking that one symbol, we will get that one. Suppose so we will get that two types of angle bisectors. So one of them is acute angle bisector, and second one will be obtuse angle bisector. Similarly, by using this formula or this theorem, we have proved that one more theorem, that is finding the pair of bisectors of the angles between the given pair of straight lines of the form of ax square plus 2hx plus by square equal to 0. So we have derived that the equation of the pair of bisectors of the angles between the pair of straight lines ax square plus 2hx square plus by square equal to 0 is h into x square minus y square equals to a minus b into xy. Again, we have discussed about that the product of the perpendicular distances. Suppose the equation of the pair of straight lines is ax square plus 2hx square plus by square equal to 0, and that suppose p alpha comma beta is any point in between these two straight lines, then the product of the perpendicular distances or product of the perpendiculars from the point p alpha comma beta to given pair of straight lines is, that is, modulus of a modulus of a alpha square plus 2h alpha beta plus b beta square by under root of a minus b whole square plus 4h square. Again that we have derived one more form, that is finding the area of the triangle. Area of the triangle formed by three straight lines. So first side will be one pair of straight line and one will be straight line will be there. So therefore the area of the triangle will be, that is n square into under root of h square minus ab by am square modulus of am square minus 2hlm plus bl square. Square units will be there. Now today we are going to discuss that number one, condition for the equation to represent a pair of straight lines. Next one is condition for the equation to represent a pair of parallel lines and finding the distance between those pair of parallel lines. Now let us discuss about that theorem. If the second degree equation s equal to ax square plus 2hx square plus by square plus 2gx plus 2fy plus c equal to 0 in the variables of x and y represents a pair of straight lines, then we have to prove that number one, abc plus 2agh minus a square minus bg square minus a square equal to 0, and that second one is h square greater than equals to ab, and that g square greater than equals to ac, and that f square greater than equals to bc. Now here we have to prove that if the given equation s equal to 0, to represent that s equal to 0 as a pair of straight lines, we have to prove that two conditions. First one is abc plus 2fgh minus a square minus bg square minus a square equal to 0, and that second condition is h square greater than equals to ab, comma g square greater than equals to ac, and that f square greater than equals to bc. Here, given that s equal to 0, let us assume that s equal to 0 equation as first equation. Let us assume that s equal to 0 represents two straight lines. Let they are L1x plus M1y plus N1 equal to 0, and that L2x plus M2y plus N2 equal to 0. We have taken the two individual straight lines which is representing the given equation. Means we have to write the combined equation of these two, second and third equation, means we have to multiply these two equations, and we will get that after simplification, that is L1x into L2x, that is equals to L1 L2x square plus L1x into M2y, L1 M2xy, that is L1 M2xy, plus again we will get that one more xy term, that is M1y into L2x, nothing but L2 M1xy, that is L2 M1xy. Similarly, that is y square term is, that is M1 M2 y square. Next x term will be, that is L1x into, that is constant part, that is N2, that is L1 N2x. Again that constant part into, that is L2x, that is L2 N1x, that is L2 N1x. Similarly, that y term, that is M1 N2 plus M2 N1y plus N1 N2. So comparing on both sides, we will get that. So comparing the coefficients of like terms on both sides. In this case, that is here L, that is quotient of x square is L1 L2. Here in this quotient of x square is A. L1 L2 equals to A. Similarly, quotient of xy L1 M2 plus L2 M1 equals to 2H. Again, quotient of y square M1 M2 equals to B. Again, quotient of x L1 N2 plus L2 N1 equal to 2G. Again, M1 N2 plus M2 N1 equals to 2F. Constant part on both sides is N1 N2 equals to C. So now we have to find out a value, that is we have to find out that 2F, 2G, 2H, product of these three things. We have to multiply these three things. That is, we have to find out the value of 2F, 2G, 2H. Already we have discussed that 2F value equals to, that is M1 N2 plus M2 N1. Again, 2G equals to L1 N2 plus L2 N1. Next to 2H equals to L1 M2 plus L2 M1. We have to multiply these three things. We will get that, that is 2F equal to M1 N2 plus M2 N1, 2G equals to L1 N2 plus L2 N1, and 2H equals to L1 M2 plus L2 M1. Now, simplifying this equation, that is, first of all, we have to multiply these second and third brackets. That is, while multiplying these two terms, we have to write in a order, one specific order. First, we have to write that L terms, after that M terms, at last N terms. So here also we will get the same manner. That is, while multiplying that L1 N2 into L1 M2. So here in this case, L1 means L1 square. After that, we have to write that M2. Again, N2. So that is nothing but L1 square, M2, N2. Similarly, L1 N2 into L2 M1. Nothing but here L1 L2 and M1 N2. That is L1 L2 into M1 N2. Similarly, multiply with that second term. That is L2 N1 into L1 M2. That is L1 L2 M2 N1. L1 L2 M2 N1. Similarly, L2 N1 into this last thing. That is L2 L2 means L2 square. Next to M1 N1. M1 N1. So we will get that four more terms. That is two terms are there in that second bracket and two terms are there in that third bracket. 2 into 2 means 4. We have to get that the 4 terms in the expansion. That is 1, 2, 3, 4. So similarly, again we have to simplify. Means we have to multiply with the terms of that first bracket with the terms of that second bracket. So again we have to multiply. So that is M1 N2 into L1 square M2 N2. Nothing but L1 square, that is M1 M2 into N2 square. See here, we will get the same thing. L1 square, M1, M2, N2 square. That is L1 square, M1, M2, N2 square. Similarly, this M1, N2 into this thing. M1, N2 into L1, L2, M1, N2. That is nothing but L1, L2. M1 is 2 times is there. That is M1 square. Again, then M2 also 2 times is there. That is N2 square. That is L1, L2, M1 square, M2, N2 square. Similarly, first term into this third term. That is, we will get that. That is L1, L2. Next to M1, M2. We will get the total things, complete things. L1, L2. Here M1 is there. M1 here is there. M1, M2. Again, then N1 here is there. So N2. So we will get all the terms. That is L1, L2, M1, M2, N1, N2. Next, this first term into this last term. That is L2 square. Yeah, again M1 square. Next, N1, N2. Now we have to multiply with that second term. That is M2, N1. We will have that. That is M2, N1 into L1 square, M2, N2. Nothing but L1 square. Here M2 square. Next, N1, N2. That is L1 square, M2 square, N1, N2. Next, this second term into this second term. That is M2, N1 into L1, L2, M1, M2. That is L1, L2. That is M1, M2. Next to N1, N2. Total things will be there. Once again, we got that all the things are there. That is L1, L2, M1, M2, N1, N2. Similarly, we got one more time. That is L1, L2, M1, M2, N1, N2. Similarly, this first term into this third term, that is L1, L2, that is M2 square. M2 is repeated and N1 also repeated. That is L1, L2, M2 square, N1 square. Next to this second term into last term, that is nothing but L2 square, M1, M2, next to N1 square, L2 square, M1, M2, N1 square. After expanding all these terms, we have to do one thing. Just see here, just observe this step. So from all these terms, now first of all, we have to take that L1, L2 as common. So from all the terms except these two terms, so which are covered total terms L1, L2, M1, M2, N1, N2, and this L1, L2, M1, M2. We should not touch this one. Just we have to write total things at last of this step. So from remaining terms, we have to take that L1, L2 as common. We have to take that L1, L2 as common. So L1, L2, having that L1, L2 term, what is that? So this one is there. So this one is L1, L2 term. One more term is where is there? So here, so L1, L2, M2, N1 square, M2 square, N1 square. So this is nothing but L1, L2 into M1, N2 whole square. M1 square into square means M1 into whole square. So here also we can write that by taking that L1, L2 as common, that is M2, N1 whole square. So just I am doing the same thing. Again, by taking that, so M1, M2, similarly we have to take that M1, M2 as common. By taking that M1, M2 as common, so what are those terms? So here M1, M2, having the terms, what are those M1, M2? Here it is there. So M1, M2. By taking that M1, M2 as common, here we will get that L2, N1 whole square. Again, where is it? So M1, M2 here. M1, by taking that M1, M2, that is L1, N2 whole square. Just see here. So we will get the step. By taking that L1, L2 as common, we will get that M1, N2 whole square plus M2, N1 whole square. Similarly, from the remaining terms, I am taking that M1, M2 as common. We will get that remaining terms are L1, N2 whole square plus L2, N1 whole square. Next, third one is by taking that N1, N2 as common, we will have that remaining terms are L1, M2 whole square plus L2, M1 whole square. So already by adding those two terms, that is, so here L1, L2, M1, M2, N1, N2 is that this term is two times. That's why we can add that plus 2 into this total thing. So just observing this step. So in that each and every term, that is, so this bracket part is of the form of a square plus b square manner. So here this already we know that in the a plus b whole square expansion, we can write that a square plus b square can be written as a plus b whole square minus 2ab. From the expansion of a plus b whole square, just by deleting the term 2ab term, so we will get that a square plus b square value. Similarly, so just assume this term as a and this term as b. It is of the form of a square plus b square. So these two terms can be written as a plus b whole square. So a plus b whole square minus 2ab, 2 into m1 into m2 n1. So while writing that m1 n2, m1 n2, m2 n1, just we have to write in a specific order. So write m terms at one place and n terms at one place and taking that 1 and 2 in the serial order. Similarly, by writing that this second term also, so m1 m2 into here also it is in the form of a square plus b square, that is a plus b whole square minus 2ab, that is m1 m2 into, that is l1 n2 plus l2 n1 whole square minus 2l1 n2 into l2 n1, nothing but that is minus 2l1 l2 n1 n2. I have written that, that is 2 L's at one place and 2 N's at another place. Similarly, by writing that third one also, so nothing but N1 N2 into, that is L1 M2 plus L2 M1 whole square minus 2 L1 M2 into L2 M1, nothing but that is N1 N2 into L1 M2 plus L2 M1 whole square minus 2 L1 L2 M1 M2. Now I am writing this step as it is at last step, isn't it? That is 2 L1 L2 M1 M2 N1 N2. So this is there. Now we can write that already we have that just see here, observe here, while writing, just we have to be careful. So here, so we are writing that, yeah, by taking that L1, L2, here inside that bracket, no L will be there. So M and N will be there. That's why we have to remember that step, M1 N2 plus M2 N1 whole square. Similarly, by taking that M1 M2 as taken as common, so here M1 M2 terms will not be there in the bracket side, inside the bracket. Only remaining terms will be there. L and N terms will be there. That is L1 N2 plus L2 N1 whole square. Similarly, by taking that N1 N2, that is L1 M2 plus L2 M1 whole square minus 2 L1 L2 M1 M2. So here, now just substituting the values. Just see here, already we have taken that, that is we have taken that L1 L2 as A, and that M1 N2 plus M2 N1 as, that is 2F. Again that, here 2 M1 M2 N1 N2, that is 2, this is B and this is C. Again that M1 M2 equals to B. Next to L1 N2 plus L2 N1, nothing but 2G will be there. This is 2AC, that is 2G square minus 2AC. Again that this is N1 N2 equals to C. L1 M2 plus L2 M1, this is equals to 2H, that is 2H whole square minus 2, this is L1 L2 equals to A, this is B. Again that plus 2ABC. Now just substituting the values. That is, in this case, in the left hand side, we have taken that product of 2F, 2G, 2H. That is 2, 2, 2 means 2 into 2, 4, 4 into 2, 8. That is 2F, 2G, 2H. That is 8FGH. In that right hand side, we will have that L1, L2 is that A into, that is 2F whole square minus 2BC plus B into 2G whole square minus 2AC plus C into 2H whole square minus 2AB plus here 2ABC. Next, after simplification, we will have that A into 2F whole square, 4F square minus 2BC plus B into 2G whole square, 4G square minus 2AC plus C into, that is 2H whole square, 4H square minus 2AB plus 2ABC. Now here, just simplifying that, now writing the positive terms and removing the brackets in the right hand side. That is A into 4F square, that is 4AF square. Next, after the positive term, that is 4BG square plus 4CH square. 4AF square, 4BG square plus 4CH square. Next, we have to write the negative terms, that is minus 2ABC. Next to minus 2ABC, that is minus 2ABC. After that, get last, we have to write that plus 2ABC. So here, these two terms will be cancelled. That is minus 2ABC plus 2ABC will be get cancelled. So after simplifying that, we will have that, that is 8FGH equals to 4. So from this all the terms, that is 4AF square plus 4BG square plus 4CS square minus here only we will have that these two steps only, these two terms only. Therefore, these two terms will be cancelled. These two will be remained. From these two terms, we will have that minus 2ABC, that is minus 4ABC. From all these terms, we can take that 4 as common. That is 4 into A square plus BG square plus CH square minus ABC. So here 8FGH equals to 4 into A square plus BG square plus CH square minus ABC. Again we have to simplify. So here this 8 can be written as 4 into 2. So we can cancel that 4 on both sides. Here 2 will be there in the left hand side. That is 2FGH equals to, the remaining term will be there. That is A square plus BG square plus CH square minus ABC. Now rearranging the terms and writing in a order, means taking all these terms toward the left hand side, writing in a order. We will have that ABC plus 2FGH minus AF square minus BG square minus CH square equal to 0. So there is a small idea to remember this step. So here already alphabet starts with that A symbol. That's why we have to write that A, B, C. So just we have to write that three terms continuously A, B, C. After that, skip that two terms. That is place two terms. After skipping that two terms, after A, B, C, D and E will be skipped. That is next terms. What is that? F will be there. That is 2FGH minus here we have to write these three terms by using that. So here first term is A is there, here first term F is there. That's why we have to write that AF square minus AF square. Next minus BG square minus CH square, like that. We will remember like this. In this manner, it will be very easy. So therefore the condition is ABC plus 2AGH minus AF square minus BG square minus CS square equals to 0. We have to check one more condition, that is H square minus EAB. What is the value of that H square minus EAB? Already from that, so we have taken that 2H equals to L1 M2 plus L2 M1 was there. So therefore, we want only one H value. H equals to L1 M2 plus L2 M1 by 2. H square value. We have to find out H square value. So that is L1 M2 plus L2 M1 by 2 whole square. This is H square minus AB value. Let us find this H square minus AB value. Minus AB value. A equal to L1 L2 and B equals to M1 M2. After simplifying that, so here, so a fraction whole square means what? Squaring the numerator and denominators individually, separately, we will have that. So that is L1 M2 plus L2 M1 whole square by 4 minus here L1 L2 M1 M2. After simplifying that, taking that 4 as LCM, its LCM, we will have that L1 M2 plus L2 M1 whole square minus 4 into this thing L1 L2 M1 M2 minus 4 into L1 L2 M1 M2. While writing this step, we can write that 4 L1 M2 into L2 M1. Now writing that another step. So this numerator is of the form of A plus B whole square minus 4AB. Already we have that A plus B whole square. In that A plus B whole square, A plus A square plus B square plus 2AB minus 4AB. So while writing that plus 2AB minus 4AB minus 2AB will be there. So we will have the expansion of A square plus B square minus 2AB. Nothing but A minus B whole square. We will have that A minus B whole square, that is L1 M2 minus L2 M1 whole square. Here A equals to L1 M2 and B equals to L2 M1. That is A minus B whole square by 4. So by writing that, again it has a single square of a single term. Now here we can write that L1 M2 minus L2 M1 by 2 whole square. So here square of any number must be greater than 0 or equal to 0. It will not be less than 0. That's why we got so the value of that H square minus AB greater than 0. So we got that is H square minus AB greater than equals to 0. So by using this condition, by taking that minus AB right hand side, we will have that, we will get that H square greater than equals to AB. Similarly, we can show that remaining terms, that is G square greater than equals to AC as well as that F square greater than equal to BC. Therefore, that condition that the given equation to represent the pair of straight lines is, that is, if to represent that S equal to 0 to represent the pair of equation, an equation of pair of straight lines, then both the conditions should be satisfied. First condition is ABC plus 2FGH minus A square minus B square minus A square must be equals to 0. Second condition is, that is H square greater than equals to AB and G square greater than equals to AC and F square greater than equal to BC. Both the conditions should be satisfied. Those are, that is if and only if means what? That is if it represents the pair of straight lines, these two will be satisfied. That is ABC plus 2FGH minus A square minus B square minus A square equal to 0 and that A square greater than equal to AB, G square greater than equals to AC and F square greater than equals to BC. So here Suppose if any condition is not satisfied, so this is first condition and this is second condition. So of these two conditions, if any condition is not satisfied, then that equation S equal to 0 cannot represent a pair of straight lines. To represent the pair of straight lines, both the conditions should be satisfied. Let us solve one problem by using this theorem. That is, we have to show that is, we have to prove that the equation 2x square plus xy minus 6y square plus 7y minus 2 equal to 0 represents a pair of straight lines. Just now only we have discussed that to represent the given equation a pair of straight lines, to both the conditions should be satisfied. So just we have to check for those two conditions. First of all, we have to compare the given pair of straight lines, given equation with the pair of straight lines, that is ax square plus 2hx square plus dy square plus 2gx plus 2fy plus equal to 0. So in this case, just we have to compare the coefficients of the like terms of the both the equations. That is, quotient of x square is a. Here quotient of x square equals to 2. That is, a equals to 2. Similarly, we will have that a equals to 2. That is, 2h equals to 1. Means 1h equals to 1 by 2. B equals to minus 6. And here it has no x term. No x term. That's why. So therefore, the coefficient of that x is 0. That is, g value equal to 0. Next to y term, 2f equal to 7 or f equals to 7 by 2. At last, the constant part c equals to minus 2. So we will get that all these values a, h, b, g and f and c. So just we have to substitute all these values in the condition of ABC plus 2FGH minus A square minus B square minus C square value. Let us find its value. That is ABC. Here A equal to 2, B equal to minus 6, C equal to minus 2. That is ABC plus 2FGH 2FGH. We here G value equal to 0. Therefore, we will get this term as 0. Next, minus A square minus AF equals to 7 by 2 whole square. AF square minus BG square minus B equal to minus 6. G square 0 square minus, that is minus 2. C equal to minus 2. C H square 1 by 2 whole square. After simplification, we will have that is 2 into 6 minus 12. Minus 12 into minus 2 plus 24. That is plus 24. Here, this second term will be 0. 0 into something will be 0. That is second term will be 0. Next here, 7 by 2 whole square. 49 by 4 into 2. That is 2 into 49 by 4. Similarly, this term also will be 0. 0. Next here, 1 by 2 whole square is 1 by 4. Next to minus 2. Minus 2 into 1 by 4. After simplifying one more time, we will have that plus 24 here. That is minus 2 into 49 by 4. 2 times. That is 49 by 2. Next here minus into minus plus. That is 2 into 1 by 4. We will have that 1 by 2. So here, by taking that 2 as LCM, we will have that is 2 into 24 is 48. That is minus 49 plus 1. That is 48 plus 1. That is 49 plus 49 minus 49 will be, numerator will be 0. 0 by 2. 0 by 2 nothing but also 0. So we got that is ABC plus 2AGX minus A square minus BG square minus A square all equal to 0. Similarly, let us check for that another condition. So another condition is, let us find that value of that h square minus AB. What is the value of that h square minus AB? Again, we know that h equals to 1 by 2. That is h square 1 by 2 whole square minus AB. A equal to 2 and B equal to minus 6 minus AB. That is 2 whole square. Sorry, 2 into minus 6. Let us find its value. That is 1 by 2 whole square is 1 by 4. That is minus into minus is plus. 2 into 6, 12. That is 1 by 4 plus 12. That is nothing but 4 is the LCM. That is 1 plus 12 into 4, 48. 48 plus 1, 49. 49 by 4, which is positive value. That is 49 by 4 is greater than 0. So in this case, we got that h square minus ab greater than 0. Or by taking that minus ab right hand side, we will have that h square greater than ab. Similarly, let us find that f square minus bc value. So that is f square. Here, what is f value? 7 by 2. 7 by 2 whole square. Minus bc. Minus again b equal to minus 6 and c equal to minus 2. F square minus bc. That is 7 by 2 whole square equals to 49 by 4 minus. Here minus into minus plus. So plus 12 is there. That is 49 by 4 minus 12. Here also 4 is the LCM. That is 49 minus 12 into 4, 48. 49 minus 48, that is 1. 1 by 4, which is positive value. So we got that f square minus bc also greater than 0. So in this case, that is f square minus greater than 0, f square minus bc greater than 0 means taking that minus bc right hand side, we will have that f square greater than bc. Similarly, by testing, that is checking that third one also, that is g square minus ac value. G is already 0, that is g square minus ac, that is 0 square minus 2 into minus 2, which is that is 0 square. Here minus into minus 2 into minus 2, we will get plus 4. 0 plus 4 is 4. 4 greater than, always greater than 0. So therefore we got that g square minus ac greater than 0 means what? We will have that g square greater than ac. So therefore that we got that. So first condition is ABC plus 2AGS minus A square minus B square minus A square equal to 0. As well as that, we have these two conditions are satisfied. Therefore, that the given equation, that is 2x square plus x square minus 6y square plus 7y minus 2 equal to 0. This equation represents a equation of a pair of straight lines. Next, second one, we have to discuss one more theorem, that is condition for pair of parallel lines. So similarly, if the equation s equal to that 0, that is s equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents a pair of parallel lines, then we have to prove that first, second, third terms, that is first one is h square equals to ab, and second condition is af square equal to bg square, and we have to find out the distance between those parallel lines. That is the distance between the parallel lines equals to, we have to show that 2 into under root of g square minus ac by a into a plus b. That is nothing but 2 into under root of f square minus bc by b into a plus b units. So here, this is a given pair of straight lines. Let us assume that s equal to 0, that is equation 1. So let us, one equation represents two parallel lines. So those two parallel lines are L1 equal to 0 and L2 equal to 0. That is L1 equals to Lx plus My plus N1 equals to 0, and that L2 equal to Lx plus My plus N2 equal to 0. So already we have that. So the equation of this straight line is of the form of ax plus by plus c equal to 0. We know that the any equation of the straight line which is parallel to the straight line ax plus by plus c equal to 0 is of the form of ax plus by plus k equal to 0, means only that x and y terms will be same, and only that constant part will be different one. So therefore, so I am taking that these two straight lines are parallel each other. Now I am taking that these two constant parts will be different one. Therefore, these two straight lines will be parallel each other. Now we are taking that these two straight lines are parallel lines which represents the given equation 1. Now after taking that, second and third lines are lines represent the given pair of straight lines 1 equation. Now I am writing the combined equation of second and third straight lines. So now again we have to equate that LHS and RHS. Just while multiplying these two terms, we will have that LX plus My plus N1 into LX plus My plus N2. So while multiplying, that is LX into LX, we will have that LX whole square, nothing but L square x square. Similarly, LX into, that is My, that is LX My, that is LMXY. Again that Lx into N2, that is Ln2x, Ln2x. Similarly, My into Lx, that is My, that is Lmxy. Similarly, we got that Lmxy, and here one more Lmxy. So just writing all these terms, so we have that terms L square x square plus 2 Lmxy plus m square y square plus L into N1 plus N2 into X plus M into N1 plus N2 into Y. Again that at last that constant term will be N1 into N2. That is N1, N2. Now comparing on both sides, we will have that. So the quotient of the like terms of the quotient of the like terms on both sides. Here, quotient of x square is L square is there. Quotient of x square is A is there. L square equals to A. Similarly, that is quotient of xy. That is 2h. Here 2lm is there. So 1lm equals to 1h. That is lm equals to h. Similarly, that quotient of y square, m square equals to b. M square equal to b. Similarly, that quotient of x, that is L into n1 plus n2. That is 2g is there. L into n1 plus n2 equal to 2g. And that quotient of y, m into n1 plus m2 equals to 2f. Lastly, n1 n2 equals to constant part c. N1 n2 equals to c. Now let us prove that first term, which is that is h square equals to ab. We have to prove the proof for that h square equal to ab value. Already we have that from the term lm equals to h or h equals to lm. H equals to lm. But after taking that h equals to lm, just we have to square on both sides. Squaring on both sides. That is h whole square equals to lm whole square. Nothing but h square equals to l square m square. Already we have that L square equals to A and that M square equals to B. So we got that first condition. That is H square equals to AB. Second, let us prove that second condition. That is that is A square equals to BG square. Again, from that we have that L into N1 plus N2 equal to 2G and that M into N1 plus N2 equal to 2F. I am taking these two terms to prove that second result. That is, so I am taking these two terms. After taking these terms, I am writing that L into N1 plus N2 by M into N1 plus N2. I am writing this second term as a denominator of this first term. So just writing this, that is this L into N1 plus N2 by M into N1 plus N2 equals to 2G by 2F. I am writing the same thing. Just see here, L into N1 plus N2 by M into N1 plus N2. In the right hand side also we have to do the same thing, 2G by 2F. In this case, we can cancel that N1 plus N2 in the numerator and N1 plus N2 as in the denominator. So we have to cancel both the terms. So we will have the, again in the right hand side also 2 will be get cancelled. So writing that remaining terms. That is, in that left hand side, L by M will be there. In the right hand side, G by F will be there. So after getting that, this is L by M equals to G by F. Now after getting this term, we have to square on both sides, squaring on both sides. So in the left hand side, L by M whole square. In the right hand side, G by F whole square. That is L by M whole square equal to G by F whole square. We will have that L square by M square equal to G square by F square. But already we know that L square equals to A and that M square equals to B. So that is G square by F square. After getting that A by B equal to G square by F square, again we have to do the cross multiplication. We will have that is A F square equals to BG square. So we got that second condition also. A F square equal to BG square. Let us find the distance between those two parallel lines. So already we have that the formula in our straight line chapter. Suppose Lx plus My plus N1 equal to 0 and that Lx plus My plus N2 equal to 0 are any two straight lines, then the distance between those two parallel lines, if those two are parallel lines, then the formula to finding the distance between those two parallel lines will be, that is modulus of n1 minus n2 by under root of L square plus M square. So we have studied this formula in our previous chapter, which chapter, that is in the chapter of straight lines. So we are using the same formula. So that is, so in this case, that is distance between those two parallel lines. Second and third will be this one, modulus of n1 minus n2 by under root of L square plus M square. Now rewriting that. So already we have that condition, that is A minus B. A minus B can be written as, that is under root of, that is A minus B can be written as under root of A plus B whole square minus 4AB. Again, we can write that A, suppose X can be written as root X whole square. So here also, here modulus of n1 minus n2 means, well, this is a positive value. So this can be written as under root of n1 minus n2 whole square. Already we know that n square value equals to A and that m square value equal to B. So here we will get under root of n1 minus n2 whole square by under root of A plus B. So here also, now writing that this is of the form of A minus B whole square. We know that A minus B whole square can be written as A under root of A plus B whole square minus 4AB. Root A minus B whole square can be written as root A plus B whole square minus 4AB. Here under root of A plus B as it is. Now just we have to substitute. But we know that is n1 plus n2. Now I am taking that this n1 plus n2 value as, just see here from this step. So n1 plus n2 equal to, that is 2g by L. So already we have that L into n1 plus n2 equal to 2g is there enough. So from this step, that just by taking that L outside, we will have that n1 plus n2 equals to 2g by L. I am using the same condition, same term, that is n1 plus n2 equal to, that is 2g by L. Again that 4 into n1 into, already we have that this is c value, that is 4c, that is 2g by L whole square minus 4c by, this is A plus B. I am writing this total terms under a single root symbol, equal to under root of this 2g by L whole square means what? That is squaring individually, that is 2g whole square equals to 4g square, L square equals to, that is A. I am substituting that L square value as A, that is minus 4c by A plus B. Now in the numerator, LCM will be A will be there, that is 4g square minus 4ac by A. That A will be, again it will be in it will in the part of that denominator part, that is A into A plus B. Already A plus B is there, that is we have to multiply with A, that is A into A plus B. So that is equals to, from this numerator part, I am taking that 4 as common, these two terms, that is 4 into g square minus AC. Again that after taking that 4 as common, just taking that 4 outside becomes 2, that is 2 into 1 of g square minus AC by A into A plus B. Similarly, by taking that, instead of that n1 plus n2 equal to 2g by L, and we have, if we take that 2f by m, we will have that is g square minus, we will get that second result. So just see here, instead of that taking that n1 plus n2 equal to 2g by L, if we take that n1 plus n2 equal to 2f by m, we will get that second result. Both the results will be same. Similarly, we will have that the distance between the parallel lines is, that is 2 into under root of f square minus bc by b into a plus b. Therefore, the distance between those two parallel lines will be, that is 2 into under root of g square minus ac by a into a plus b, or 2 into under root of f square minus bc by b into a plus b. Okay. Let us solve one problem, that is by taking that previous theorem, that is show that the equation ax square plus minus 24xy plus 18y square minus 6x plus 9y minus 5 equal to 0 represents a pair of parallel lines. And we have to find out the distance between these pair of parallel lines. So here given the equation is s equals to 8x square minus 24xy plus 18y square minus 6x plus 9y minus 5 equal to 0. So comparing above equation with that s equals to, ax square plus 2x square plus by square plus 2gx plus 2f plus c equal to 0. Here also, just by comparing the coefficients of the like terms of these two equations, or that is x, that is quotient of x square is 8, here quotient of x square is 8, that is a equal to 8. Similarly, h equals to minus 12, b equals to 18, g equals to minus 3, and f equals to 9 by 2, c equals to f equals to 9 by 2, and c equals to minus 5. Let us substitute all these values in our condition. Let us check that h square equals to ab. Let us substitute all the values. H square, here h equals to minus 12 whole square, h square equals to a equal to 8, b equal to 18. Let us check whether h square equal to ab or not there. H square equals to minus 12 whole square, a equals to 12, b equals to 18, minus 12 square equals to 144. 18 into 8 also 144. So we got that 144 equal to 144 means we got the same thing, h square equal to ab. First one is proved. Let us check for that. A square equal to bg square, a f square, a 8 f square, f equal to 9 by 2 whole square equals to bg square, b equal to 18, g square equals to minus 3 whole square. We have to simplify on both sides. That is 8 into 9 by 2 whole square, 9 9 81, 2 2 4. So 8 into 81 by 4, that is 4 4 1 time, 4 2 times, 2 into 81. So here also 18 into, that is minus 3 whole square. Minus 3 whole square equals to 9. 18 into 9. So after simplifying that on both sides, here in this case, that is 4 into 2. 2 into 81 is 172. Again that 18 into 9 also 172. So we got that 172 equals to 172. Therefore, we have proved that second one also. Let us find out the distance between those two parallel lines by using the formula 2 into 1 half g square minus ac by a into a plus b. Already we have taken the values a equal to 8 and that h equals to minus 12, b equals to 18, g equals to minus 3, f equals to 9 by 2, c equals to minus 5, and substituting all these values in the formula 2 into 1 of g square minus ac by a into a plus b. So that equals to 2 into g square. G equal to what is that? Minus 3 whole c equal to after simplifying that, we will have that 2 into under root of 9 plus 40, 9 plus 40 by 8 into 26. So we will have that we will have that 2 into 49 by 8 into 26, that equals to 2 into 49 by here 4 into 26 can be written as, that is 13 into 2, that is 8 into 2, that is 16. 16 can be written as 4 into 4 into 13. So by taking that 4 outside, that will be 2. 2 will be cancelled. That is here root 49 is 7 and here 4 is, that is 13 into 4, 52. We will have that 7 by root 52. So that is the distance between those two pair of parallel lines. That is 7 by root 52 units will be there. So, dear students, so in this session we have discussed about that if the equation represents the straight lines, pair of straight lines, just we have to it has to satisfy those two conditions. So that is nothing but, so that is ABC, if the equation ax square plus 2hx square plus by square plus 2gx plus 2f plus c equal to 0, 2 represents a pair of straight lines. Two conditions should be satisfied. So that is ABC plus 2fgh minus a square minus bg square minus a square equal to 0, and that one more condition also. So that is also you have to satisfy. So what are those? Just see here. So in this session we have discussed that is to represent the pair of straight lines. These two conditions should be satisfied. Just see here, ABC plus 2fgh minus a square minus b square minus a square equal to 0, and that a square greater than equal to ab and g square greater than equal to ac and a square greater than equal to bc. Again that, so to represent if the given equation to represent the pair of parallel lines. So that is, what is that condition there? Just see here. We have discussed that yes, if the equation s equal to a square plus 2h square plus by square equal plus 2gx plus 2f plus c equal to 0, represent the pair of parallel lines. So we have to check for the condition a square equal to ab and that a square equal to b square, and that the distance between the parallel lines equals to 2 into root of g square minus ac by a into a plus b, that equals to 2 into root of f square minus bc by b into a plus b. By using these two formulae, now we have to solve the problems. Just see here. We have to try the problems. That is, show that the given equation 2x square minus 13xy minus 7y square plus x plus 23y minus 6 equal to 0 represents a pair of straight lines, and we have to find the acute angle between the lines. To find out the acute angle between them, what is that formula? The formula to be used, that is cos theta equals to modulus of a plus b by under root of a minus b whole square plus 4h square. So by using those formulae, we have to solve this first problem. Next, we have to find out that is we have to show that the equation 9x square minus 6xy plus y square plus 18x minus 6y plus 8 equal to 0 represents a pair of parallel lines. We have to show the given equation, show the pair of parallel lines. After proving the equation represents the pair of parallel lines, we have to find out the distance between them also. So we have to use that second formula. Okay. So therefore, students, just you have to try these two problems. Thank you, students. Thank you, one and all.
Thank you, Srinivas garu, for a detailed explanation. And I'm sure all the students will solve the questions that you have given, and they will also visit the previous sessions if they have to refer the problems related to the angle between the pair of lines or angle bisectors, equations for angle bisectors. And thank you so much for a wonderful explanation. Thank you, sir.
Thank you, madam. Can I stop the chair?